Welcome everybody to the first Unfolding Tomorrow event of 2022. Today our topic is life underwater, the SDG number 14 of the United Nations. Today we have here three great panelists, Emil Lyman, Mari Saario and Sini Harkki. My name is Arto Skvarek. I'll be moderating today's panel discussion. I'm from Aalto ES, member of the board for this year. And we also have here some people from AVP, which we are collaborating together to bring this great event to you. Next up, we'll have an opening speech from Finnish Environment and Climate Change Minister, Makari. And without further ado, I think we can move on to that.
Dear friends and colleagues, thank you for the invitation, especially as we are all here because we share a common worry for our beloved, unique, and extremely vulnerable Baltic Sea. It breaks my heart to see the troubled state of our waters. First, a few words on actions taken and results achieved. In the Baltic Sea, we have long traditions of working together in the Baltic Sea Environment Protection Commission, HELCOM. HELCOM adopted the revised Baltic Sea Action Plan in 2021. It includes about 200 new actions to improve the state of the Baltic Sea, combining both measures in the catchment area and at sea. This work is also tightly linked with the global actions such as the UN Sustainable Development Goals. To implement the measures successfully, we also need a solid science base. The HELCOM's science agenda connects to UN Decade of the Ocean Science, providing a common framework to ensure that ocean science can fully support countries to achieve the 2030 Agenda for Sustainable Development. Finland, as one of HELCOM's contracting parties, is fully committed to implement the action plan also nationally. And one of the most important goals for Finland is to remove the archipelago sea from HELCOM's list of hotspots. Dear friends, Finland is also doing a lot nationally to save the inland waters and the Baltic Sea. On December, we took a government decision regarding our updated marine strategy and river basin management plans. The primary goal of these plans is to reach a good status of the waters and the marine environment. The best way to save the Baltic Sea is to improve the state of waters in the catchment area of the Baltic Sea. Finland has several national funding programs and projects in order to reach the good state of waters. We are, for example, allocating 69 million so far for improving the state of our inland, ground, and marine waters towards a good status. We will bring operators together, ensure funding for measures, and create continuity in water and marine protection. In particular, in the drainage area of the Baltic Sea and coastal marine areas. We, for example, want to reduce phosphorus leakage from farmlands by using gypsum, structural lime, and fiber. Our primary area for these actions is the drainage area of the archipelago sea in order to improve the state of the archipelago sea and remove it from HELCOM's list of hotspots. Actions also include restoring wetlands and rivers water management in urban areas, farmlands, and forests, and removing oil from shipwrecks in the Baltic. These funds will also go to research, in particular for studying the state of the archipelago sea, as well as for communicating and outreach. In this accord, I want to mention the EU's Biodiversity Strategy for 2030 and the nature protection and restorations targets. These aim to improve the state of biodiversity, mitigate and adapt to climate change, as well as prevent and reduce the impacts of natural disasters. In this strategy, Finland has committed to the protection of 30% of EU's lands and sea areas. To me, it's clear that in Finland we have to be able to reach at least that. The planning of national implementation of the strategy and Finland's commitment by 2030 is ongoing right now. We have already done and still do a lot to improve our knowledge, status, and the protection of the underwater biodiversity through several national, international, and EU projects. We, for example, want to improve the effectiveness of the network of marine protected areas and for identifying locations with red listed species and habitats. We have also carried out restoration efforts in inland and coastal waters. Also, the Finnish Helmi restoration program covers partly the aquatic environment. Dear friends, the protection of our waters must be even more effective today than it was in the past, due to fundamental threats like climate change. Climate change makes it more difficult to reach a good environmental status of our waters. But we need to continue to protect the underwater biodiversity and improve the state of our waters. I am therefore pleased to say that the EU multi-annual financial framework for 2021 to 2027 provides new funds for fighting climate change, research, and biodiversity protection, and for saving our waters. We have a lot to do and a long list of measures to implement with the aim to improve the state of our waters. The successful implementation can only happen by active cooperation between different sectors. We need everyone joining forces to fight against the climate crisis and loss of biodiversity globally, and also here in Finland. It means science, governments, NGOs, arts, common people, technology, business world, investors, and the list goes on. I hope you can find your role in this and come up with smart ideas on how to save our waters. Thank you.
Thank you very much, Emma, for your very honest and inspirational speech. Definitely, the problem is very big, and Finland is definitely tackling it as best as it can. But Finland can't do it alone, and we need also the action of individuals, companies, and future decision makers, that is, students. We here at Aalto ES, at Startup Sauna, where we are right now, we are trying to mold the next generation of builders for Finland. That means entrepreneurs, project managers, NGO leaders, creators, everybody who is trying to drive change in a society and the world that we live in. So basically we're trying to bring our own part to this, the solution of the pollution of the sea. Next up, we'll have the introduction of our panelists. We'll start with Emil Nyman. Emil Nyman is a researcher and in Helsinki. He is specialized in the coastal areas of the oceans, and he's a marine biologist. Emil Nyman, welcome. Would you come up to the stage, and thank you very much.
All right. Thank you for the introduction, and thank you for inviting me to give a speech at this seminar. I'm going to talk more specifically about our coastal seas, our as in not owning them, but ours as all of ours together. We have a responsibility to take care of them. And we're going to look specifically into some certain areas of concern with the Baltic Sea specifically. Could I get the next slide, please? So our coastal seas are important. That goes without saying. But why are they important? We have, they are areas of high biodiversity. They are areas of high productivity. They provide us with a very diverse ecosystem services, valued up globally up at almost $13 trillion a year, which is a huge amount. And what is important to recognize is that these ecosystem services support human well-being, but in an interaction, in an interaction of ecosystem services and human activity. Human activities can't alone sustain our well-being. Yes, could you please give me the next slide? Thank you. But our coastal seas are also threatened by a multitude of activities. I bring up here as the first point eutrophication, which I'm going to talk more about. It's an overarching problem in our coastal seas. But there are obviously a lot of other problems too. For example, the chemicalization of the environment and loading of harmful substances, which are also affecting the system in a very overarching way. But with regards to eutrophication, we have to remember it's also a natural phenomenon. We've always had coastal sea areas that have less nutrients and more nutrients. So eutrophication is the process where the input of plant nutrients increases the productivity of the coastal areas. And it's a completely natural phenomenon. And thus, we also have organisms that are, of course, adapted to a spectrum of levels of eutrophication. With human activities, areas that are affected by human-induced eutrophication have increased, and thus we have areas that, or an increasing amount of areas of coastal seas display symptoms where we have the ecosystem and the community of species is shifted towards organisms that are adapted to high nutrient concentrations. And these are usually organisms that thrive on aggressive strategies to survive. The faster you grow, the better. And this leads many times to very cyclical population sort of growths and declines, which again leads to that we have very large biomasses of organisms that also die in droves, which means that we also, they leave behind them a lot of dead biomass and decay, so to speak. And that's what we have, for example, with cyanobacteria blooms and beaches covered with dying algal biomasses. Overall, when speaking about eutrophication, most of the nutrient loads that cause this come from agriculture. That's speaking on a basin-wide scale for the Baltic Sea and globally too. But these problems are always scale dependent, so when looking at this problem, when we go down into more detailed levels. For example, in urban areas, stormwaters are a big problem and causing localized eutrophication. We have 50% of the global population lives within a very narrow coastal zone. So these coastal zones are highly pressurized, and the coastal terrestrial habitats are severely modified, as can also be seen in the aerial image from a part of Helsinki where development is ongoing. These changes in pervious versus impervious surfaces causes large runoffs of nutrients and suspended solids into the water, which changes the system. Nationally, of our coastal areas, approximately 50% of the coastal areas are estimated to be under the influence of built areas. In urban areas, it's more than 75%. And this, of course, leads to the intensive and diverse pressures we see in our coastal areas nowadays. Could I get the next slide, please? So why should we be worried about this? We should be worried about this because our coastal seas and our seas and ecosystem in general are complex adaptive systems. They're networks of interacting units of biological beings. These kind of systems are exemplified by emergent properties, and a phenomenon called hysteresis is very prevalent in these kind of networked systems, and we see alternative stable states. So what are emergent properties? They are, for example, what we see in our coastal seas now, the manifestation of eutrophication. We have interacting units causing, for example, turbid waters. There's a network of things happening underneath that cause this one property to emerge from an interaction of properties. Hysteresis means basically then that this system, because of the structure of the system, it has an inherent resistance to change, which is exemplified in the graph by the red lines. If we wouldn't have hysteretic effects, we would move up and down along a response with a changing pressure in a linear way. But with hysteretic systems, we have a resistance to change, an initial resistance to change, but then when a pressure goes far enough, the system flips into an alternative stable state. And here it is depicted by what has happened in the Baltic Sea. We've moved from a clear water stage where submerged vegetation was abundant into a turbid water stage where pelagic production and algae floating in the water are abundant, thus sort of hampering the growth of submerged vegetation because they affect the light climate underwater. But getting back to the original state also has a resistance. So even if we reduce the pressures, we necessarily don't immediately move back towards the previous state. And even if we're able to reduce the pressures enough, we most likely will never return to the state where we left from, because the system, as I stated in the beginning, is a complex network of interacting units, and they most likely will not reorganize in a similar way that they from where they started. And in the Baltic Sea, it has been shown that we have exceeded critical thresholds, and we have changed from a clear water system with abundant top predators into a turbid water system that is characterized by a strong microbial loop. We have exceeded this because our nutrient inputs to the system have been too large. There are nowadays MAIs, maximum allowable inputs of nutrients, that have been scientifically come up with by the HELCOM Commission. And for example, nitrogen, the allowable input into the Gulf of Finland alone is about 100,000 tons per year, and for phosphorus around 3,500 tons. These relate to current loads in a way where we would need to reduce nitrogen inputs by about 20% and phosphorus inputs by over half to reach these allowable inputs. And even that won't guarantee that we will return to a better state of the system. So, and in order to reach these levels, we actually need to, as we heard in the previous talk by the Minister of Environment and Climate Change, we need to have a holistic approach, and we need to have a combination of measures and an extensive both remediation and source input cut approach to this big problem that we face. Yes, could I get the next slide, please? So do we see these effects in our data that we collect daily? Here I'm showing on the left total nitrogen loads into the coastal sea outside Helsinki, and on the right total phosphorus loads into the coastal sea outside Helsinki. And we see a typical development of increasing nitrogen loads. We see this elsewhere in the Baltic too, up until the early 90s, where then wastewater treatment plants mainly have implemented technological improvements into the wastewater treatments, and our nitrogen loads have been reduced significantly. For phosphorus, the technological advancements came a lot earlier, so the loads have been reduced, at least since the 1970s, from where we have consistent data. This looks really promising. We've actually reduced a lot of our external loads into the coastal sea of Helsinki, but do we see these effects in the sea? Could you give me the next slide, please? This is then again the response in the sea. On the left, we see the total nitrogen concentrations in the seawater, and on the right, the total phosphorus concentrations in the seawater. And as we can see, the nitrogen concentrations follow more or less the figure I showed from the load amounts. It goes up to the early 90s and comes down when the load decreases. But this the time period of high loading did nudge the system into an alternative stable state, because we see for phosphorus the concentrations have been increasing despite drastic reductions in external loads. And what this is caused by the historical large nutrient loads have overwhelmed the system, which buries phosphorus nutrients into the bottom of the sea, and it doesn't hold on to the nutrients anymore and bury them in the sediments, but it has started releasing nutrients from the bottom of the sea. So this can be seen in the constant increase in phosphorus concentrations in our coastal seas. So these are the kind of problems we're tackling with, and this is why we need to act fast and we need to act strongly. We can't wait and do half measures. We have to actually grab the bull by the horns and do everything we can at once. Could you give me the next slide, please? So just to round up and leave you with some thoughts, we need to really consider ecosystem services that our coastal seas provide us and truly incorporate them into the costs that we create by occupying Earth. We can't go on thinking anymore that human activities and the natural environment are detached from each other. They have to truly be combined in the way we plan the use of our environment. Currently employed partial measures to improve the state of the environment can actually be harmful. We need to be really holistic about this and do everything at once, because these partial measures may cause this false sense of security, and people think that things are going in a better direction, whereas we actually would need to be putting more effort into this. And we see this in many signals in the natural environment. So with this, I'd like to thank you for the opportunity to come and speak here, and I'll step down from the stage and give the turn again to our moderator. Thank you.
Thank you very much, Emil. I mean, the science is at the center of this issue, and simplifying it will simply not do. Especially it was interesting to see how the drastic reduction in emissions does not always equal the drastic response in the oceans. Sometimes they may be muted, and we need to do more to actually reach our goals. Next up, we'll have Sini Harkki. Sini Harkki has had a long career in NGOs. Right now, she's a program director at Greenpeace. Welcome to the stage, Sini.
Yes, thank you. And indeed, yes, just to maybe say I'm program director at Greenpeace Nordic. So covering, we have offices across the 4 Nordic countries, and also we cover a bit of Iceland. So that's me. And good seeing all of you today. I don't know who's behind the camera, but nice that you are there. I think I have to say to begin with that for me it was quite hard to refocus on oceans today and the sea, because as many of you probably, I've been quite swamped with the war situation and the Ukrainian situation the last few days, because of course we are an international organization and also operating in Eastern Europe and Russia, and there's a lot there to reconsider, also to consider what does it mean that Europe is facing this very urgent situation to cut some of our addiction to oil and gas, which of course is something that is on our agenda every day, but now it's on everybody's agenda. So I've done my work now to refocus on oceans, and I think it's really good that we are having this talk, because in times like this, it's hard to think about alternative futures, to think about how to build a better tomorrow. It's maybe harder now than it has been in a long time, but it's also more necessary than ever. And I think when we talk about oceans, it's quite key to, of course, also talk about climate change and our ecosystems and planet as a whole. And on Monday, in the midst of all the news about war, there was also a new report published by the Intergovernmental Climate Change Panel, IPCC, and it carried also quite a heavy message. Not surprising to anyone, of course, that it is a grim situation, and I think this time it was great that the report really has a renewed and strengthened focus on ecosystems as well. So what we got out of this report, I think some of the main takeaways would be that the impacts of climate change and warming are advancing even faster than we thought before, that the urgency to both cut emissions and mitigate the impacts that will happen, even if we do everything we can to cut emissions now, is even higher. And that this decade that has started is going to be absolutely critical. It's going to define a lot of how this century and the next centuries to come will be like for humans on this earth. And the other main takeaway, besides the even heightened urgency, would be that oceans and forests, the ecosystems, the main ecosystems that we have that are absolutely vital for human survival, are suffering greatly from climate change, from pollution, from industrial activities, and we need them in our fight on climate change. They're absolutely vital. Oceans, for one thing, have absorbed something like between a fifth and a third of carbon dioxide so far emitted by people to the atmosphere. Forests have done some big work there as well. So they are actually the best buffer we have against climate change, oceans and forests. And by constantly polluting them, constantly disturbing the ecosystems, we're making it harder and harder for these ecosystems to help us and keep taking up carbon. Also, all of our great ecosystems are also approaching some critical tipping points. So some of the things that go on in oceans and the sea were just described well by Emil, and there's similar really critical thresholds, for example, for forests, where we know that at certain levels of warming, it could be at 2 degrees, it could be lower, it could be a little bit higher, but somewhere there comes a point where, for example, tropical rainforests are likely to just dry up and die. And we also see a lot of increasing forest fires in the northern hemisphere, which means that this cycle will then start making climate change worse, and also will make it increasingly difficult to hold on to these ecosystems that are really critical for our very own survival. And the same goes for oceans. There's climate change is causing warming and acidification. At the same time, we're doing industrial activities such as huge fishing, deep sea mining as a new thing, extraction of fossil fuels in the sea, plastic pollution, activities like bottom trawling that effectively wipes out everything from the sea. And that is also making it very, very difficult for our ocean ecosystems to help us binding carbon, providing us with oxygen, providing us with food that so many people rely on. So at this moment, for the reason of biodiversity loss, but also increasingly and really urgently for climate change, it's very, very important that we protect these ecosystems. More important than ever. That really is the case now, although it's often said. And for oceans, Minister Makari also mentioned that there's the EU Biodiversity Strategy, which is great. Greenpeace has been working for several years now to push for a new United Nations Ocean Treaty that would make it possible to protect the high seas, the oceans that are not on any nation's territory, but are common to all of humankind. We don't have the international legal instrument yet to protect these, yet we know that from science that we would need to protect at least 30% of our oceans in order for these ecosystems to have a chance of survival. So that's something we've been working on very hard to make that instrument exist. In the EU, there are certain commitments made, but actions still lag behind a lot. And we need to see a lot more action in the next few years to really protect at least the 30% of both our land-based ecosystems, including forests and oceans. And in addition to that, of course, there's so protection is the first step to make sure that these ecosystems could still thrive and work and provide us with everything they provide us with at the moment. But then, of course, there's also all kinds of indirect ways that we threaten these ecosystems, such as increasing carbon dioxide in the atmosphere or other kind of pollution to the oceans, or eutrophication in the Baltic Sea especially. And these are quite difficult to tackle because they're of course like really complex issues, and many are directly linked to the structures and ways of working of our current economy, our current consumption model, which is still very much based on constant overuse of natural resources and a throwing away culture. So in order for us to really be able to tackle, for example, plastic pollution and some of the other pollution problems to the sea, we also need to move towards really circular solutions in the economy. So there's a lot of work ahead, for sure. And what could be Finland's role there? I think it's very important that Finland actually has been one of the quite good players in the EU and global ocean politics. That's been a wonderful change because in forest policies, Finland is always the bad guy. Still in the EU is. So it's important that we use the weight that we have in the EU and in global politics to the maximum to make sure that some of these critical steps happen. And then, of course, there's our own example, what we do to our own sea, Baltic Sea. And there a lot has happened, but still many challenges remain. One of them being that our agriculture and forestry still produce a lot of nutrients that run freely to the Baltic Sea, and that challenge remains largely untackled. Yeah. Okay, I think that's pretty much what I want to say. So this was a completely freestyle speech because I had no time to prepare, so the ending was maybe a little bit abrupt, but thank you.
Thank you very much, Sini, for the great improvised speech. I couldn't tell it was improvised, it was so well planned out. But also, thank you very much for bringing attention to the IPCC report. I think it might have gone under the radar for many of us because of the crisis in Ukraine. But it is still a very critical report, and it outlined quite drastic predictions for the future. But yeah, next, final but not the least, in the slightest, we have Mari Saario. She is a sustainability director at Sulapak. Would you come to stage? Thank you.
Thank you. I'm Mari Saario, and today I'm mostly here speaking as a role of sustainability director of Finnish startup Sulapak. But I'm also in my current now, meaning that before that I worked over a decade in consulting business, in Gaia Consulting. So today I start from the point where the last speaker ended. What should we do in Finland? Because today here I want especially focus on our quite a unique opportunity here in Finland and in Baltic Sea to really put together working, sustainable, industrial ecosystems, meaning that here what we have research, we have innovation, we have startups, we have technology, we have a very little corruption, we have a really good trust between enterprises and the authorities. I know as a consultant, because when I discuss in Europe, especially in the global level, that how these two parties can really discuss together in Finland, that is possible. So that's why it's possible to put together pieces and really develop methods for growing, producing food, taking nutrients back, recycle those nutrients, recycle wastes, recycle biomaterials, and that is my topic of this speech. So here I have our material package of Sulapak. You may open the webpage of Sulapak there to the screen, because our target is that, that you will find the additional answer from our webpage. And this is an old version. During this year, you will also get the new version where we focus even more of our impacts to sustainability, especially in worlds of bio. Because when we are discussing about the bio and food and materials and packaging, that is the word we used to use much more, the bio, instead of plastics. Because in bio, we discussed about biodiversity and how the current unsustainable use of plastics is affecting the biodiversity, especially in oceans, also in our Baltic Sea. And we need to discuss the words like bio-based or bioeconomy, meaning these new materials we need, where they come from, where the raw materials we need to replace fossils, where they come from, and the key here, how we make them recycle. And then finally, we need to discuss about biodegradability, because as we know, humans are humans, and there always will be litters. And as we all know from social media, from research, how does the plastic litter look like in oceans? And it remains there, it stays there. It's the accumulation of plastics in oceans, also in Baltic Sea. And with accumulations, I mean that fossil-based plastics are not biodegradable. Of course, with erosion, with in different conditions, they got breaking smaller and smaller and smaller pieces. But conventional plastics made out of fossils, made out of oil, they never end up the food for microbes. So that's why we need to replace plastics. And that's why, as last speaker, or actually all of the speakers mentioned, one of the biggest threats to biodiversity, the climate change, and our need for decarbonization, cutting our use of oil, then we also need to discuss about plastics. And we can't just say that, oh yeah, let's recycle the plastics. Because as long as we recycle the plastics, it's never 100%. We still need new oil, which means that we will add new carbon to the system, which means that when we are using the plastics, there will be always the plastic litter. And when that litter ends up to the nature, for one reason or another, there was always, I think we all see that in social media, the discussion that if you recycle plastics, whether it ends up in the sea in China. Well, that's not true. For example, in Scandinavia, in Finland, there are a lot of good recycling innovations and already a very good first system for recycling plastics. But that's not enough. We get just a small share of actual plastic molecules to finally recycle to new products. And as long as there are leaks from the system, as a form of litters, like the empty plastic bag flowing to the sea, or the form of microplastics, when it ends up in the ocean, finally it ends up as microplastic, microscopical small fragments of plastics, which are not food for microbes, meaning that they are not be part of so-called biogenic cycle, and that's where we enter the word bio again. So our biocycle is broken, and our fossil cycle feeds in material in the form of microplastics and plastics that the nature, biodiversity, ecosystem just can't literally digest, meaning that they will stay there. What is their impact? It's still so less known that when we are discussing as a startup, making products, replacing conventional plastics, we hear that it's impossible to measure microplastics because there are no metrics for this. So, but it doesn't say poof and disappear, it stays there. And we know that these fossil-based plastic polymers in ocean, they might last decades, even maybe hundreds of years. We don't know yet. And because of the accumulation, it means that every year there will be more of that. And now, according to the newest research, there are signs that these microplastics are already part of the so-called deep sea circles, meaning that we will find more microplastics from biodiversity hotspots in oceans. And at the same time, that even in atmosphere, the microplastic particles are quite often ocean-borne, meaning that microplastics from the ocean end up to the atmosphere. So they are part of these natural cycles. And if we think that there is like the technical machine and we'll throw some sand in there and suddenly the machine stops working because there is sand everywhere. That is practically what we are doing now. We are throwing in the sand in the wheels of ecosystem services without actually knowing how much it can handle, what will happen if the microbes take in the little pieces of microplastics. They do. How effectively will they work? We know that species in the ocean take in little pieces of microplastics. They do. What is the impact for that? We even know that every human being ingests a certain amount of microplastics. And there are some research about the potential mechanical infections or low-level irritation, or maybe the links that how the actually hazardous chemical molecules from the nature could then end up to the single cells or the human beings or the fish in the surface of microplastics. So that's why we need to replace this whole world of plastics with bio-based materials. And that has to be sustainable too, meaning that, well, that is where we end up in Sulapak. We want to use materials that are biodegradable. But if you check this kind of piece and you put this to the home compost, if you give it enough time, you can find it there. But according to current standards and systems, this is not considered biodegradable because, well, you can't see it, but there are, for example, little dark pieces, which is the side stream wood. So if you put this to the water, it doesn't biodegrade to carbon dioxide because there are pieces of wood, so you will actually get a little pieces of wood, more humus, more biomass. But our current standards, our current legislation, our current systems do not take that into account, that what is the actual result. Because those standards, they are based on idea that bio-waste is something that you peel off the banana and throw it away. So you can't recycle these kind of materials in composting because that is for the food waste. And you can't recycle it with the plastics because, well, it's not fossil plastics. We want to recycle it in our own cycle. There are technologies for this, especially, originally I'm a biochemist, especially if you add enough engineers and biochemists to the same room and then add some money, you will get chemical recycling, meaning that we can take carbon, biogenic carbon, and change that to other new recycled bio-based polymers. So practically, with these kind of materials that, for example, Sulapak is making, we can take side streams in the future, and already today, we can take side streams, like from the forest industry, the sawdust, the finest material that is not used for anywhere else. In the later phases, we can, for example, take materials like biochar. We can take side streams or waste-based materials for use as new feedstocks. And we can make bio-based polymers recycle, but still, because humans are humans and no recycle is 100% sure, it means that there has to be the way to understand that there is a difference if the litter is fossil-based plastics or if the litter is something like this, which ends up, give it some time, as a wood and some bio-based polymers, which are food for microbes and are digested by microbes and return to the biogenic cycle. So why this is not happening, and this is like the end part of my speech, is that we need to change not just regulations and not just politics, but policy. Because today we are mostly discussing about plastic recycling as an important method, and there are even now discussion in Europe that several countries or even EU would ban materials like this because there is no recycling system. So it means that in the future we would just, keep the plastics. And after this, what you heard, I think that is not sustainable if we think the oceans. So we need more understanding of bio, we need recycling for bio, and we need to understand how we replace plastics as one important method for decarbonizations and cut off our linkage to the oil drilling. Thank you.
Thank you very much, Mari. Especially interesting points about the current loopholes in the legislation of new plastic, new biodegradable plastics or materials to replace plastic. Don't go anywhere. We'll set up the panel stage here. It will take us a few seconds. In the meantime, you could actually refresh the YouTube page, because there will be a link where you can, in the description, there will be a link where you can post your questions, and then we can add them to the discussion of our panel. Thank you very much. I think we can sit down and start our discussion. All right, has everybody got some water? Great. Ocean water. All right, let's start the discussion. I think we can start off by laying out some basis for the further discussion. First off, would you, Emil, like to explain a bit more about what are the main sources of pollution for the marine ecosystem, oceans, and maybe then explain a bit how they differ from each other, mainly, for example, coastal areas versus open seas, and different mechanics behind this. Thank you.
Yes, so to start off with the Baltic Sea, it has a few peculiarities that do not apply to other European coastal seas. One of them is that the Baltic Sea is fairly shallow, and we have a fairly slow water exchange, which make it more vulnerable than coastal seas in general. And then we have in relation to the total volume of the Baltic Sea, we have a fairly large drainage area. And the drainage area, especially in the south, is highly populated and also has a large fraction of agricultural lands. And this also applies to Finland, for example, where we have a large fraction of agricultural land in the southwestern part of Finland, where most of the drainage area drains into the archipelago sea, which is again an exceptionally vulnerable area of the Baltic Sea in general, because there again we have slower water turnover times. And this sort of brings us to perhaps looking at these loads, which are sort of scalable on a Baltic Sea wide scale. River discharge and atmospheric deposition of pollutants are the main sources of loads. But then when we go down in scales, we have as external loads, for example, urban areas and stormwaters become important when we go down to the smallest scales. And then, of course, we have the internal dynamics in the sea, because we have processes that recycle nutrients and other substances into more permanent pools, for example, the sediments at the bottom of the sea. But then they cycle back at with some interval of time. So there's also this feedback loops within the sea that have to be considered when we're talking about loads.
Thank you very much. Eutrophication. I think everybody in Finland has heard it at least once. So this is rehevöityminen, and it is very, very common in the Baltic Sea and in the inland waters. But it is also, from what I know, a phenomenon that occurs in other oceans of the world also. But it is more localized in the coastal areas. So it is not just a problem localized here in Finland, it is also a global problem for the oceans. Would you like to tell us more about it?
Yes, it is definitely a global problem, but it's prevalently a problem for coastal seas and shelf seas. And that's because when we get out into the open ocean, the volumes of water are just so huge that the effects of nutrient pollution get diluted to some extent. We do have areas of open ocean where we have eutrophication problems, but it's again dependent on different mechanisms. Like, for example, open ocean primary production might be limited by iron, but then again, when we have winds blowing off from, for example, the Saharan desert, bringing a lot of sand out in the open ocean, we might have huge phytoplankton blooms, sort of a manifestation of eutrophication in the open ocean. But it is mainly a coastal ocean problem. But we do have very extensive areas affected by this in different areas. Like, for example, in Gulf of Mexico, we have huge areas of oxygen deficiency, which is a manifestation of eutrophication that expand very large areas. And also the bottoms of the Baltic Sea can be considered Europe's largest desert, because there's just nothing living there. It's permanently anoxic, so has no oxygen. It's only organisms that have different metabolism, do not breathe oxygen, that can survive there. So yeah.
Yeah, that's from what I know, the hypoxic regions of the Baltic Sea are most located around Gotland in the deeper parts. So these are the places where there's lack of oxygen and basically the death of marine life in these areas. And these are, from what I know, permanent mostly, but they grow and shrink according to the eutrophication of the area.
Yeah, they basically grow and shrink mainly due to water exchange through the Danish Straits, and depending on how much saltwater pulses we have, the extent of the anoxic bottoms or hypoxic areas increase and decrease. But of course, the ultimate, or as long as the Baltic Sea has been the Baltic Sea as it is now since the last ice age, we have had hypoxic and anoxic areas in the sea. So it is a natural phenomenon, but anthropogenic eutrophication has worsened the situation.
Yeah, that is very much true. So yeah, coastal areas. Coastal areas seem to be the culmination of the problems in the ocean. So there's trash litter collecting in the coastal areas, there's eutrophication. Let's talk a bit about plastics. So yeah, Mari, you have a lot, I would say, knowledge about this probably to share with us. Coastal areas are the main sources, of course, because people live by the coast, so there's the source where the plastic ends up in the ocean. How would you describe the plastic as a material when it gets into the ocean? It is not a biodegradable, it is not a biological agent in any way, it's basically, would you describe it as a dead material in the ocean? How does it interact with the environment, and do we know if it has some chemical reactions that it might catalyze also?
Well, how to put it shortly, when there are different type of plastics, and then when we are discussing the material family of plastics, there are like additives, which we know, like when we are discussing, for example, so-called endocrinic disruptors, meaning, once again, it's also a natural phenomenon. If we eat soybeans, we actually get endocrinic disruptors, meaning like molecules which act like hormones. But the thing is that if we get additional load, so with certain additions used in plastics, for example, to give it more flexibility, there are like bisphenols and chemicals like that, which also end up to nature at the same time as plastic materials. Then if we are thinking the basic structure of the plastics, like the polymers. Polymers mean that they are, well, the long molecules made out of mostly, well, carbon, and eventually they are originated from the bottom of the dinosaur, because they are, you know, made of the fossils. So we are practically using bioplastics with the really old forests, from the really old forest. But the thing is that after the petrochemical process, what we get are these long polymer molecules that are like no-go to the living organisms. So depending on their size, if they are like we all have seen those sea turtles or something, you know, because there is no natural processes how the living individual or microbes would break it. And so that's why it's like it's in one way we can consider it like a passive material. But then there are these chemical problems, and then because of this microplastic problem, we get really small pieces of plastics, meaning that these long polymers, they get shortened by the mechanical forces, but still they do not end up molecules that some microbes would like to eat. Unlike the so-called unlike the biodegradable molecules. And that is like the actual question of biodegradability, whether it ends up to small molecules that microbes can eat and fart carbon dioxide, which is actually practically what is happening. But that is like the good type of carbon dioxide, because then we are discussing about biomass, and then we are discussing the biogenic carbon cycle, which is normal phenomenon. But the final risk, what we don't know, is that what these plastic polymers, these molecules, these little pieces actually take with them when they enter the living cell. Are they taking just those chemicals that were originally part of the plastics, or are they taking with them some other impurities? Because, yeah, so that is maybe one of the key problems, that if the living cell then afterwards can't, you know, put it out, it just have to operate around these molecules. And that's why we enter the situation where there is this sand in the machinery. We don't know actually all the impacts.
All right, so you're saying that the microplastics can also function as carriers of other pollutants into the organisms.
Yeah.
That's very interesting, and for sure also poses a danger, that unknown danger right now to the marine life. Of course, as we talk about the coasts, most of the pollution around the coasts come from the runoff areas of rivers and other water sources. and also, of course, dumping of litter and trash by the coast. But now this is an interesting question, and I would pose this to you, Sini. Rivers run through multiple countries, so not always the coastal country is the origin of this pollutant that enters the ocean. Is this posing a problem when tackling the climate crisis, or the crisis of the ocean and the pollution of the ocean? How can we source the origin of the pollutions, and how can we keep these countries or entities responsible, hold them responsible for polluting this ocean, and not just focus on the coastal countries in the world?
Yes, and I think that, that same problem is with basically any international environmental issues. We are faced with the same challenge that pollutants cross borders, and they don't care about borders, and of course it always helps if it's just one country something produces a bit less pollutants, but then how this in practice goes in, for example, environmental political negotiations internationally is that everybody's watching each other, and usually countries don't want to move first because they don't want to do some expensive new technological or political solutions without knowing that others will do the same. In climate change, we have more or less already come to the situation where many countries and companies do want to be forerunners because that it's a competitive advantage. But I would say in oceans and biodiversity issues and many other environmental issues, we still have the problem that nobody wants to go first. So it is really important to look for those ways that we can find international solutions to these things. So yes, that is definitely an issue, I would say. But also the fact that with pollution that comes from so many sources that are linked to the kind of very fundamental mechanisms of how our economy works or how our agriculture works, which no longer is really cycling the nutrients like we used to do, but more like based on also fossil fuel based materials that are used in agriculture and used once and then discarded and spilled off as nutrients to oceans and seas. So we're so far from the cyclical model that of course the pollutants come from like a zillion of sources that are not easy to tackle with policies, but for sure possible.
Thank you. Mari?
Is it possible to comment?
Yes, of course.
Thank you, because based on this too, there is not yet enough price for nutrient emissions. Practically, there is no price for nutrient emissions. I'm come also from the southern western Finland, so that archipelago area. And in my previous life, I have made several environmental permits and also like calculation that how much money, if we talk about money, I don't know if it's right to talk about money when we are actually discussing about the future of the humankind, but with carbon dioxide it has helped when we have transferred the carbon dioxide tons to the euros. So with nutrients, it's not so. So when there is this, what's hajakuormitus in English?
Diffuse load.
Yeah, thanks to diffuse load, it has no price. The big river in the southern western Finland do not have environmental permit when they load the archipelago and the sea area with nutrients and nitrogen, like phosphorus and nitrogen. But the company who would like to rent the cottages or take the tourists out or produce food in the modern aquaculture, for example, growing fish with feeding them fish actually coming from the Baltic Sea, so that we can use the side streams of the small Baltic herrings. First, eat the best part of the herring, and then take the rest, make it the fish feed it to the trouts, and then produce new fish. But it's actually next to impossible to get environmental permits, because the coastal area is so loaded already. So like nobody is paying for these nutrients. And it was like 7 years ago when we made for Sitra the first assessments about circular economy of nutrients. And there was the calculation that if I would need to, collect the phosphorus I need in my field, the price would be like 200 times. If I would need to collect that phosphorus, from the Baltic Sea and put it back to the field. So that's why there is no pricing for this. As long as it's diffuse, it's free, and it's practically taking away not just biodiversity, but also really a lot of business values of Baltic Sea and coastal areas.
Yeah, that's very interesting, because the system for pricing of CO2 emissions is actually a very well-designed system in the matter that it also helps or drives the change in the countries that are more the bigger emitters of CO2. So it is also financing the change. So something similar would probably be needed for nutrient pollution, would you so say? Yeah. All right. Now, maybe there is also an interesting topic to touch upon with the plastic. We at Aalto Entrepreneurship Society, we think that entrepreneurship is the way to create fast change, as you, Mari, for sure know, since you are working in a startup. And so for future builders, it is, from my understanding, not enough that you create a material and it is biodegradable. It also needs to be processable in existing systems, and we can't just talk about creating new materials. We also need to talk about processes and how these new materials fit into the existing process and how we might need to change the current processes. Would you say that the bottleneck of new materials is not as much creating biodegradable alternatives, but as much as incorporating the new materials into existing processes?
It depends of the end use, because with some products I would say that it's not a technology anymore. For example, with Sulapak, our key idea is that we do not need new infrastructure. You can take a normal converter, so-called converter is the facility which makes plastic things out of the plastics. And you just replace the material. And then you end up making straws or packs or whatever. But so that is like the basic idea. But mostly the thing is that how to make that functional. Because anybody who has run after his organic apples outside the shop because the biodegradable plastic bag has biodegraded right outside the door, if it's not like functional. So because the key, we have to go back again and saying that the key thing is resource efficiency, and we have to minimize our all the natural capital and resources we consume. So that's why whatever we are like creating, it should be functional, and it should be efficient, and it should be recyclable, and the infrastructure should make it so. So sometimes I think it's just not just like politics, but it's more like the policy, because it means that clients, consumers has to approve that it looks a little bit different, or the standards has to be twiggle a little so that it covers it, or the brand manager somewhere has to had to think that, oh yes, it looks different now. Well, I think we can live with that. Sometimes I think it's the biggest thing changes is within the humans' minds.
Yes, and as you said, the devil is in the details, and the execution is the key. So it is very much important to pay attention to that as our future founders create their startups to save the planet from plastic. Emil, let's talk a bit about the Baltic Sea. So you were talking in your opening speech about the how our ecosystems, environmental ecosystems, react to the reduction of the emissions. So drastic reducing emissions that not always correspond with drastic changes in the environment, because it has found a new stable state. Like you said, what is the situation right now with the Baltic Sea? What do you feel would be actions needed to be taken to reverse some of the damage that has been done now in the light of new data and information that we have?
The simple answer is to cut the source loads, and that's the main thing that needs to be done. Of course, there need to be supportive actions like ecosystem remediation or just even maybe building artificial ecosystems. So I'm not talking about the business ecosystems, but but natural ecosystems.
They can be the same.
They can be the same, but specifically in this sense. But I think the most important part is tackling the source, cutting the source loads, and there we can get back to, for example, yes, resource use efficiency, and perhaps since we know that agriculture is one of the main sources for it, we need to make fertilizer use more efficient, and it needs to be planned more in detail, and also perhaps reducing farmland in general, which we get back to how to do that is to transfer from animal production into producing food directly for humans by farming. But these are, of course, very tricky sociological, psychological questions, how to convey these ideas in a constructive way to a large public. There will always be resistance in these matters too, but well, yes, these are sort of the key concepts, I think, that we need to tackle.
Yeah, like we talked before the event briefly, we have had some quite realistic exercises in making institutional changes in our society, meaning pandemic for 2 years, and now we have another crisis on the doorstep. So yes, how would you say that, because of course change is painful always, we need to support the ones who are hurt by it the most, but we also need to keep the people who have most to let go accountable so that they change their ways. Would you say that the messaging right now and the messaging of the communicating the severity of the crisis has been adequate? Since in the face of, like we saw, the world was capable of very big changes during the pandemic when we had to do it.
Yeah.
And we are facing the same situation right now. We have to do something.
Yes.
Is the problem in communicating the severity of the issue, or what would you say is the problem right now?
I think partly it is a problem of communicating the severity, and it's partly maybe also saturation of media with repeating the same message over and over again in the same way, and not giving the public enough credit to understand complex problems. It should be delved more into depth in public discussion, and made sure that it's conveyed to all walks of society in a sort of a respectful manner, so that you take into account sort of the listeners, and convey what kind of problems this will cause in the future. And of course, it's they're very hard problems to sort of convey when people have more urgent issues to deal with. And how to do this is probably a science of its own. And I guess your organization has a lot of experience in this, so please go ahead.
Yes, it is, or there's several strands of science working on it, but it is a really complicated thing, of course, and I think, yes, there are many like psychological barriers, obviously, like the one that we've also been able to observe with the war now, that it feels like everybody now is saying that, okay, in hindsight, we could see this coming for 10 years, but we were just holding on to the hope that the worst would not happen. And there's a lot of similar things going on with how we deal with climate change, and kind of deny that urgency and deny the obvious or the apparent. But then I think it's not only that. It's of course also, yes, how media is dealing with it, where media loves to polarize instead of look ahead, find solutions, which keeps us kind of in the trenches very easily, because the way that the debate and political debate is also constructed. But then I think I would also like to raise the fact that, of course, change is also always about power. And when there's really big change happening, like there is happening now, quite often the ones who are about to lose at the moment of change still have more power. Because if you look at, for example, plastics, the fossil fuel plastic-based companies are the ones that have been on the top of the Forbes list for the last decades. The ones that produce something else are startups. Who do you think has more lobbying power to the government? Or the same with what's going on in the energy business. Solar and wind are already more affordable, more effective almost anywhere in the world to build than fossil fuels. Yet we have so many governments that are not ready to take the action to close coal plants, for example, because their friends are the ones who benefit from the coal and oil economy, because those are the companies and lobby organizations still holding a lot more money and power. And it's kind of almost too dirty and simple to say, but unfortunately it's also true. So I think we also need to be able to look at that more openly and transparently, to be able to give way for the kind of new that is coming up, because otherwise for that new to gain power, it takes way too long.
Yes. Mari,
I think I want to add one more aspect. When we are discussing about the systemic change needed by society, well, in corporate social responsibility, there are like three aspects: the social, the economy, and then the environmental. And well, just like we have seen that during the last, let's say, 2 decades, when I started as an environmental professional, it was just like, what is the absolute minimum level? Law says that the policies, do not come, and let's do that and still complain. Sorry, that was a little bit sarcasm, but not very much. No. And during during my career, these 20 and something years, now there are like corner rooms where there are like discussing that, hey, how much money we can make if we do this. I don't know if that is, and there was like a lot of discussion that also this type of economy is broken, so we can't trust like totally in it, but at least I'm still happier that change is also happening. I know that Finnish woman, Kaisa Hietala, who is now the member of the board in Exxon, used to work in Gaia Consulting, so that's why it's actually quite an interesting story, and also description how the small share of owners decided that, hey, we don't like where this company is going, and then they were the one who like worked inside the system, that now there at least there has to be expert within. But still, I think one thing from corporate social responsibility we should think more is diversity, because as myself as both like, well, I'm white, my well-being is good, but on the other hand, I'm queer, I'm the mother of neurodivergent child, and I see that how several aspects of sustainability are not actually accessible, because they are too expensive, they require certain expertise, they require or even like that they are like based on the idea that you are a certain white, able-bodied person who can then make really nice choices and take a nice Instagram and share everybody how good people they are, sorry. But so before we can really say that sustainability is accessible, we can't actually take those solutions really to the developing countries, for example. So there are already a lot of good things, but so that the especially younger generation from developing countries could take the quantum leap without going through this over-consuming middle-class type of life? I think that is one of the key questions.
A very good point. We're running out of time. This is a discussion we could have for hours. I would definitely say that the point about the accessibility of sustainability is very important, because as a consumer in a developing nation, you do not always have the choice between a biodegradable plastic product and a regular plastic product. So the question is, I would say, how can we make sure that the choices we offer consumers to the world are in fact sustainable? So this is a very big problem also. Thank you very much for attending the panel, and it has been very, very nice to talk with you, and hopefully see you in the future. To our audience, I would shout out the last day of this month, 31st of March, we have the second Unfolding Tomorrow event, and the topic will be the SDG number 7, which is renewable energy. So energy changes, basically how can we be more independent from fossil fuel energy sources, and also maybe in the light of current political developments, this is also a very, very good time to have this discussion. But thank you very much for attending. Hopefully you learned a lot, and see you in a month. Thank you very much.
Thank you.
Thank you.